Welcome to our YouTube channel of series of basic process engineering calculations. In last session, we have uh, uh, focused on the different scenarios based on the safety wall sizing is done. And in this session, we start with the first case for the calculation of relieving rate and the safety wall sizing for the thermal expansion in the acetic xylene transfer line from tank farm to the plant. So first step is to calculation of relieving rate. Okay, to calculate relieving rate, we need some data. Length of pipe from source to receiver in meter. Okay, then in meter we can consider length and all details later on. Then OD of pipe, then we required the specific heat capacity of trapped liquid. The liquid which is trapped inside the pipe, we need its specific heat. We considered approx 600 to 650 meter of length. Then we considered point 80 mm line size. Then we consider the specific heat of trapped liquid as we have considered xylene. So we'll consider other parameters, process parameters of xylene. Okay, specific heat of xylene. Okay, specific of xylene in joule per kg Kelvin. Then based on the length and the OD, we can calculate the surface area which is required for the calculation of relieving rate. That is surface area is equals to pi into d into L. That is meter square. Okay. Then we input basic parameters like specific gravity of xylene. Then we add the heat flux through solar radiation is in watt per meter square. Okay, and specific gravity for xylene we can check it from MSDS as well. For solar heat radiation heat reflux we can get it from Google or any handbook. Then we need density D1 of the xylene is it's 70 kg per meter cube. Okay, as we have seen what are the data required. Okay, initial temperature of xylene in trapped condition. we have considered 30 degrees Celsius as a transfer temperature. Then we need density of xylene at 60 degrees Celsius. We can get it from the graph, or you can just consider based on the your experience as well. I have considered on safer side. Then we required the temperature, final temperature or release temperature. Okay, final temperature of xylene we considered 60 degrees Celsius with assuming the heat flux through solar radiation. Okay, now we have all the data with us. So based on the data, we can calculate cubic expansion coefficient. Okay, which is 5, and I have already shown you the calculation formula, which is based on the density differences, like can calculate to square minus density square divided by 2 times of T2 minus T1. Okay, and into density 1 into density 2. Okay, so I guess that is in solve condition. We got the expansion coefficient based on the density differences and the temperature difference. Now we can calculate the calculated relieving rate for safety wall sizing. Okay, and for liquid I have already explained the formula in last session, so we can calculate best liquid relieving rate using that formula. I just simply drop down here, like equals to expansion coefficient into the heat flux through solar radiation into the surface area which is in contact with the uh, solar radiation. Okay, and divide by the formula 1000 into specific gravity of the xylene into specific heat capacity of liquid. That is specific heat capacity of liquid. So the we will get the value. We can consider it in number, so we will get this value of required relieving rate in meter cube per second. Okay, now we can convert that by simply multiplying 3600 seconds. So we'll get the flow rate m cube per hour. That's our required relieving capacity. So using this relieving rate, we can calculate this. Step 2 is to calculate the orifice dia. Calculation of orifice orifice. Okay, so we know we can convert that relieving rate as we have the relieving rate in meter cube per hour into, we need to convert that into gallon per minute. So we'll get the flow rate in GPM, then set pressure required of safety valve is, we can consider it 5 bar G. We can convert that into 101,325 divide into 5. So we'll get that, we need to convert that into the PSIG, sorry. So 14.7 to that, so we'll get PSIG, pressure in PSIG. Okay, so we considered over pressure of 10% as for liquid application, then we can get the, then we have mentioned set pressure 5 that converted into PSIG, then we have to, for liquid application 10% is overpressure, then based on that with adding to that 10% we'll get the set pressure around 81 psig, then back pressure is 0. So now we have to add the coefficient of discharge. So based on the data I have added the back pressure 0 psig, then coefficient of discharge kd for liquid is 0.65. If that was the case of gases, then kd value will be different. Then we have added viscosity correction factor here and the back pressure derating. Based on that we have simply put it down all the relation from the formula so that we can get the area in square inch of required to relieve that much amount of relieving rate, and based on that we can just simply done it unit conversion. Then final orifice dia is 2.23. So to size the safety valve we can give simply the required relieving rate to the manufacturer, and they can size the safety valve as per their sizing tools, and even though we can consider it as per our also, and you can tally that with the manufacturer sizing sheet also. And most of the in thermal expansion cases the orifice type and size is of D type designation, and it's 0.011 inch square area is commonly sufficient in thermal expansion cases. Hope you understood that part, how to calculate using Excel. Just practice it and drop me comment if you have any queries. Okay, thank you, see you in next session. Bye bye.